Hey, I just wanted to go over some of the data that the EPA has published on the East Palestine train derailment. I'm going to share screen in a second. And while I do that, just wanted to talk about my qualifications and why I can do this. I've worked 15 years in an environmental laboratory, specifically some of the same ones that are doing this work. And very specifically, one of the labs was in West Sacramento, where they actually specialize in dioxin and furan analysis. In fact, one of my coworkers was the actual project manager for the real life Erin Brockovich when she was looking at the chromium-6 in her famous case. So there's not a lot of labs that do dioxin and furan analysis. And I was a project manager in that in a lab that specialized in that stuff. And the reason I'm bringing this up is dioxins and furans are formed from the incomplete combustion of chlorinated hydrocarbons, AKA something like vinyl chloride. If you had tankers of vinyl chloride that spilled and were maybe set on fire in an uncontrolled fashion, it is very likely that you're going to expect to see vinyl chlorides from that. So, but right now, this is the EPA's landing page on the East Palestine train derailment. And you can see that they have air monitoring, water sampling, soil and sediment results. And on a later video, I'm going to go over these pictures and just walk through what I can deduce from looking at this kind of stuff. But for this, what we're going to do is we're going to take a drill down into some soil sample results. And that's what we're looking at here. So a couple of things. All of these samples were analyzed for volatile organic compounds by SW846-8260. So if you wanted to look this up, you would Google SW846-8260 and it would tell you about this method, SW846-8015, SW846-8270. And those are really the methods that were used. So they're looking for volatile organic compounds, the 8260, semi-volatile organic compounds by 8270, and your total petroleum hydrocarbons by 8015. And they're breaking that down from ranges. So you have your gasoline range. Those are your smaller molecules from C6 to C10. Your diesel range organics from C10 to C28, and your residual range organics from C28 on up. Over on this table, if you look at it and download it, they have the sample results. But what I wanted to show you is here, these result qualifiers are important because U means undetect. So if you scroll down, as my computer tries to catch up, the majority of these samples are undetected. Okay, so at its surface, this appears to be a good thing. Undetect. They don't put zeros because in the laboratory or scientific world, there's no such thing as zero. There is a limit of detection, and that limit of detection is a function of your lowest range of calibration or the method detection limit. So let's stop here. So you see that there's no flag here. This is a legitimate hit. And for residual range organics, we see 130,000 parts per million. So ppm is something that we talk about all the time, but maybe the average person isn't familiar with that. So a part per million, folks would say, is like a couple drops of blood in a swimming pool. That's the level of detection that we can have. So a cup of water is 1 million parts per million water, or 100% water. Okay. So this stuff that is 130,000 parts per million, or milligrams per kilogram, residual range organics, it's a lubricating oil, and it is 13%. So 13%, that's significant. And if you can see here, some of these undetects, your detection limits are very high. And they're very high because the laboratory is diluting this stuff. Let's keep scrolling. They're diluting this stuff to get the response within the linear range of calibration, or even if they're not looking for TPH, there's so much bad stuff in here that it's just blowing out these instruments. These instruments are designed to detect very, very trace levels of things. So this one's 26,000 parts per million. There we go. Sample BP1. So on that website that I showed you, you can correlate these sample locations with a map that shows you where on location these were collected from. But this sample was 460,000 parts per million residual range organics. That's roughly 50%. So, you know, the sampler, an engineering firm, took a sample of the soil, and by weight, it was 50% oil. Your diesel range organics was 4%, and your gasoline range organics was about 0.5%. My theory is that in the fire, you're going to lose your more volatile gasoline range organics and your diesel range organics. Those things are going to burn up. Your residual range organics have a higher boiling point and are going to be more persistent in the environment. So I think that's one of the reasons why this stuff is around and the other ones aren't. On my Substack, I put not the manifest, but a list of what the rail cars were that were spilled, and you can also find that on the EPA's website. So in closing, a couple of things that I wanted to talk about. The state of Ohio has control criteria, limits on, you know, the threshold of what's good, what's not good. So that's what if you were to do a cleanup, you're going to test or remove material until you're below those limits. So in the state of Ohio, to reuse contaminated soil, your C20s through C34 range, your residual range has to be at or below 5,000 milligrams per liter. Your C10 through C20, 2,000, and your C6 through C12, 1,000. So you can see that this is, you know, 5,000. We are almost 100 times greater than the maximum threshold that the state of Ohio allows. So, you know, all of this stuff is going to have to be dug up and sent away. One other thing to talk about is sending it away. Where is it going to go? RCRA, the Research Conservation and Recovery Act, is what is the laws that this stuff falls under, and benzene and vinyl chloride, their limits are 0.5 milligrams per liter and 0.2 milligrams per liter, respectively. Now, this is solid data. We're looking at what's in the soil, and a general rule of thumb that the EPA has historically allowed is 20x. So typically what you would do when you're trying to profile this stuff into a landfill is to take some of the soil, and then you do what's called a T-clip, a toxicity characteristic leachate procedure. You tumble it, and we don't necessarily care about what's in the material, but we care about what leaches out of it. So in a landfill, that leachate that's going to go back into the environment. So that's specifically what we're looking at. And like I said, there's an accepted, 20x rule of thumb. So between the solid and what you would expect to find in the leachate. So if your leachate threshold is 0.5 milligrams per liter, that means if your soil is, below 10 ppm, you're probably good. If it's below 4 ppm for vinyl chloride, it's probably good. And, there's certainly instances here where that is not the case. But just in closing, I wanted to state that, these U's that mean undetect are really, they're meaningless. It's meaningless data because the reporting limits are so high to dilution that, we might be non-detect way up here, but the analyte might be here, and then the level for threshold might be way down here. So that's just things that you have to consider when you're looking at this data.